At what point or points is the tangent line for x squared plus xy minus y squared equals 5 parallel to the line y equals negative x minus 7? Parallel lines have the same slope. The slope to the line given is the coefficient in front of x. So the slope to that line is negative 1. The slope of the tangent line is the derivative, so we will need to take the derivative of the equation x squared plus xy minus y squared equals to 5. This is an implicit equation. It involves x and y, but it's not solved for y in terms of x, so we will have to take the derivative implicitly. This is done by taking the derivative of both sides with respect to x. On the left side, the first term, the derivative will be 2x. The second term is a product rule. The derivative of the first, derivative of x, is a 1 times the second left alone y, plus the first left alone x times the derivative of the second. The derivative of y is 1 y prime. Every time we take the derivative of y term, we will have a y prime due to the chain rule. The third term, negative y squared, will be a power rule. Bring down the power, multiply with the negative 1. Subtract 1 from the power, but since we need to multiply by the derivative of the inside, the chain will produce a y prime. We just took the derivative of a y term once again. Equals to, on the right side, the derivative of a constant is a 0. We will want to solve for y prime here. Let's rewrite, to simplify the look of this expression, 2x plus the 1 is implied, so we can just write that as y, plus the 1 is implied, so we can write that as x, y prime. And then we have the minus 2y, y prime, equals to 0. We have two terms that have y prime in them, and we have two terms that do not have a y prime in them. We want to solve for y prime as a function, so we need to isolate the y prime terms. Here's the two of them. To have fewer negative signs, I'm going to move those over to the right side. That way the two terms that are here will stay positive. It will just give us fewer negative signs. So we will have 2x plus y equals 2. Moving the terms over, the 2y y prime will become a positive, and the x y prime will become a negative as they move over. They will switch signs. We can now factor a y prime out, so 2x plus y equals to y prime times 2y minus x. And we can solve for y prime by dividing both sides by 2y minus x. So y prime equals 2x plus y over 2y minus x. This is our slope of our tangent line, and we therefore can make it parallel to the line that was given by setting it equal to its slope. Parallel lines have the same slope. What this will do is give us a relation between y and x. We can now multiply this up to the other side, and we will distribute the negative 1 in. So we have 2x plus y equals negative 1 times 2y minus x. So 2x plus y equals negative 2y plus x. Let's subtract x from both sides, so we have x plus y equals negative 2y, and now subtract y from both sides, so x will equal negative 3y. There's the relation between x and y that will make this situation hold true. We want to find the points, and this will be found by taking this relation and finding the points by plugging into the equation originally given. Our points are on that curve, and have a relation that x apparently needs to be negative 3y. So the original implicit equation given to us was x squared plus xy minus y squared equals to 5. Everywhere we see an x, we can put in a negative 3y. So we have a negative 3y quantity squared. Negative 3 squared is positive 9. Y squared is y squared. Negative 3y times y will be a negative 3y squared. And then minus y squared equals to 5. We can combine all the terms on the left. 9 minus 3 is 6, minus 1 more is 5. So we have 5y squared equals to 5. We can divide both sides by 5, so y squared equals to 1. And we can take the square root of both sides, or we can subtract it over and factor. It works out either way. It factors as a difference of squares. No matter how you look at it, we will have y able to be a negative 1 or a positive 1. Now we want the points, so we want the x and y coordinates, but we do have a relation between x and y. Once we have the y, we can find the corresponding x. So if we start with y equals to negative 1, x will be negative 3 times negative 1, which is a positive 3. So the x-coordinate is a 3, the y-coordinate is a negative 1, and there's one of our points. We also had y equals to 1, in which case x will be a negative 3 times a positive 1, which is a negative 3. And we'll have x-coordinate of negative 3 and a y-coordinate of 1. And there's our 2 points where the tangent line for the equation was parallel to the given line.